Welcome everyone to week 4 of practical R workflow for scientists, namely for us, for NOAA fisheries scientists. And this week I'm going to be talking about organizing your code into an R package. And so, back in week 1, I talked about the motivation behind these kind of mini workshops that I'm doing is to help you move in the direction of making your code more compartmentalized, documented, extendable, reproducible, and robust. And when you start working on a project where you have you're working with a lot, like you have a lot of scripts, you have a lot of functions, a lot, I don't know, 5, that's a lot. Definitely if you're getting up into 30, that's really a lot. But once you start getting, you have multiple scripts, it's a little more complicated. Then organizing your code into an R package is really going to help you make it more robust, easier to work with, and definitely much easier to document. Next week, we're going to talk about documenting within the R package system, and you're going to see how easy and powerful it is. It's really kind of mind-blowing how easy it is, and the nice documentation you can create just as seamlessly as part of your natural coding workflow. Okay, so that's even for a personal on a personal side, right? You're not planning to share your code with other people. It's just for yourself. Even for yourself, an R package, in my opinion, is really well worth it. I use it constantly, just because it makes my work so much easier to document, and just makes it so much more robust, easier to debug. And then extendable, if I need to use, so I have some functions and I'm using it for, say, papers or reports, I then can just call that package. I kind of keep the coding part. That's not like making specific pictures for a paper. So like I may have like the data processing part, or the modeling part. That would all be in a package. So even if you're doing it just for yourself, it's definitely absolutely still worth it. If you get where you're making something that you're going to share with people, you absolutely want to make a package. It'll be so much more robust than like sending them scripts and stuff. You're going to see why. Okay, so now that we've got a fair number of people, we're about 4 minutes in here. I'm going to post the link to what I'm going to be going through in the chat. So when you come back, everything I'm going to talk about, you're going to see this on that web page that I just linked there. You can follow along there too if you want. And then as we go along, as usual, go ahead and post comments, questions in the chat, and I will get to those and answer those. If somebody else in the group knows the answer, absolutely feel free to put your answer in there. This group interaction here. Okay, so to start off, if you have everything installed, you got RStudio installed, go ahead and open that up, and we can just kind of do this together. We're going to make a package. Show you how easy that is. I'm just going to make one de novo through RStudio. So I'm going to go to RStudio. There we go. And you can see I already had something open. I was testing, make sure I could do what I'm about to show you. So I've got that the RStudio window open, I'm going to go up in the top right corner here, and I'm going to click that, and then I'm going to say New Project, save by okay. Then New Directory, because I'm making a new package. Say our package. I'm going to give it a name. You want to just copy and paste the code that I have on that website. You should name yours New Package. That's what I use. I just need that. Look at if it's in the right place. Later, I'm going to show you how to connect this up with GitHub. It'll be the same for GitLab for those of you who are using that. Similar workflow. I'm going to show GitHub. So I'm going to go ahead and check this box here to create a Git repository. That'll just save me having to make it a Git repository later. If you don't check this and you want to make it a Git repository later, that's fine, super easy. You just go to Tools and then the project option, you click a checkbox. But I'll save myself a step and I'll click that. And let's go ahead and create it. All right, there we go. I have created an R package. That was it. That's how hard it is. Now in RStudio, you see this tab called Build. So let's go over here. I've clicked on the Build package, and now you see this button called Install and Restart. So I can rebuild this package. Go ahead and do that. Just show you what that looks like, how it looks, goes through. What it's doing is it's going through the code in this. I'll show you that in a moment. And it's making sure it all works and rebuilding it. And then now it has both installed it and then it's also loaded it. You can see it says library new package. So that's package, loaded it. And now the functions in this package are accessible to us. I want to take a brief moment and say something for your Windows users. So I'm on a Windows machine for teaching this. I also use a Mac on both. On Windows, you may or probably have to install RTools. And that shouldn't be too hard, but people sometimes run into problems where RStudio can't find RTools, and you can search on Google to help you out there. You can email me, ask me, because I've had to deal with this before. It's just a matter of RStudio not knowing where RTools is. In my experience, like when I set up a new computer or I reinstall, I upgrade R, the new version has come out. I personally always have the IT do that for me, and they do that at the admin level. And for me, that works well. And then I just make sure that my packages, that I can load packages. They're really familiar with doing that. So that's always been good for me, and I haven't had any problems when I've set up a new computer. But I know through emailing that a number of people who have installed RTools locally have sometimes run into trouble. So like I said, first try Google, because a lot of people have had that trouble, and then ask me, because like I said, I've run into that before. But once it's all installed, it works great. Like I said, I'm on a Windows machine, works fine. My desktop at work is Windows. When I'm at work, I'm normally developing on a Windows machine. Okay, great. All right, so we have now made our first package, and now let's talk about the elements of what makes something an R package. So there are three key things. There's really only three key things. That is this file called the description file. Audio is sketchy. Oh dear. Anybody else? I'm on a little bit. Audio's fine. Okay, good. I think that hopefully. Okay, good, good. Okay, okay. That's you, Paul. I'm on my home network this time. Okay, great. All right. So the three key files are this description file, namespace, and then this R folder. So let's go through them one by one. So I'm opening up the description file, and this is just the template that RStudio made for you, made for me when I did that create new project to make an R package. And so this is like the minimal stuff that you need. You know, it's just your name, package, title, the version. You know, all this is stuff that you put in. It's just specific to your package. For the license, if you are a NOAA employee, if you go onto that setup tab and those folders from IT about using GitHub, which is in there is going to be a link to what to use for a license as a government employee. There's a specific one we use, so just go on there. That's not actually specific to GitHub. That's going to apply to any like publicly made software. Okay, so that's kind of it. We're going to add a few things to this description file because right now this is very minimal, and I'll go through the extra things. The extra things I'm going to go through that later, but basically what we're going to do is we're going to add the dependencies, which is what packages does your package depend on. This is really key because remember, think about whenever you install something, like it'll probably install some other packages. And what it's doing is it's making sure that that package has everything that it depends on. And if you've ever shared like scripts with people, you probably run, or you've gotten scripts with people, you run into the situation where you try to run it and then it says, I don't have this package, I don't have that. You get really frustrated. When you do a package, you specify everything it depends on. So when you install that, it's going to install all its dependencies. So you will run into that problem of not having packages. Okay, so that's description. Okay, namespace. When you first look at them, it's going to look weird, but it's actually a really simple thing. So the namespace is just specifying which of your functions are going to be available to the user at the command line without having to do : : : So : : okay, so what do I mean there? I'll give you an example. You know, like if I had a function called foo and it was hidden, if I did new package : : foo, I would have access to that, even if it was " hidden. And in the namespace, what you're doing is you're saying what packages are not hidden. So what packages I could just type foo and they would just run if foo is within my package. So what you're gonna see in the namespace, this is kind of, ignore that top line for the moment. So, you know, if I had a function called foo, I would put export foo. So it's just saying what I'm going to export to the user. What this top line is doing here, what RStudio did for you, is that just says export every function. So what's going to happen is any function that you put into the R folder is going to be accessible. That's all you need to know about namespaces right now. just accept the default. Don't touch the namespace in the beginning when you're getting used to folders, getting used to packages. Just leave this. It'll export every function that you make. That's fine when you're starting. Okay, so description, namespace, and then this R folder. And within the R folder are functions. They must be functions. They cannot be scripts. They must be functions. So if we look here, our package has one function. Those are the comments. Let's go down here. So we have one function, and it's called hello. So let's try that. So we have loaded this function, and we have, we have loaded this package, and we have this function within our package. So now we can say hello, and it did it. Hello world. All right. Okay. So now we have this pretty simple package, a very simple package. It has one function called hello, and it doesn't have anything else really. So we're going to add something to it. We are going to add a new function. So what we're going to do is we're going to go here. This is up in the top left for a new new file, our script here. And I'm going to make a function, and I'm going to call it little forecast. Actually, I have the code over here. Wait. That question just a second after I show this. Okay, so here's my little code for my function here. I'm going to copy that code. And now I'm going back here, and I'm going to paste it in. And now I need to save it, and it's important for me to save it in the R folder, because the R folder is where all the package functions are kept. So here I'm at the R folder, and I'm going to save it. I could call it anything. I don't have to call it little function. Your package does not care about your file name. It will just look at the functions that you have. But I and basically everyone will call their files by the function name, because that way you can find them later. And that gets to this question that somebody asked, which is for a package, does each function have to be in its own script? By that, I think you mean, does it have to be in its own file? No, it doesn't. So if you had a whole bunch of little functions and they are all your little utility functions, you might have a file called utility functions.r. And then within that, you would have, you know, one function, and then you would have another function. You can have as many as you need. Okay, you can put a whole bunch in there. Now, the reason people don't tend to do that a lot, or they only do that with really, you know, small, like utility functions, is that it's going to hinder your documentation of your functions. And next week we'll talk about documentation, and you'll see how that comes into play. The other thing is that even if that weren't the problem, you'll you know, if you have a lot of functions, you can start getting lost. It can be hard to find where the function is, and it just gets things a little more disorganized. So pretty much everyone will have a separate file for each function. Okay, so great. So now we've added a new function to our package. And if I were to hit install and restart, I could now type, let's go back here, code here. I need to get some data for this. Okay. So let's go here. I can use this, copy that. So WW usage is a data set that you have just by default. Everybody has that. All right. So now it's created, it made the function, and now what my little function does is it takes any data, a vector of data, and it will fit a ARIMA model to that and run a forecast for in number of years. All right, so it's that simple. On the website, I talk about editing your namespace, and I show this line here that you can go in and you can say export little function. I didn't have to do that because remember RStudio put at the top of my namespace that little thing of code that says export all the functions. If you didn't have that line up there, then you would need to add this export little forecast. In my own packages, I don't use that line that RStudio gave you because I don't want to export everything. So I have a line, export little function, export next function. I have, maybe, 20 of these little export lines in my namespace file. Okay, so the next question, someone said, what about the dependency that we just introduced by the forecast? How do we deal with that? And so that gets us to the next part, which is editing our description file so that we document this dependency. Now, you notice that for me to personally run it, that dependency didn't have to be stated because I already have forecast on my laptop. So it works fine. The dependency here is for it's documenting your dependencies, but also when you share it and somebody else installs it, it's going to make sure they install everything that they need. So it can be, so the reason I kind of mention that is it can be easy to forget to add your dependency to your description file because your package isn't going to stop working if you forget. So you have to kind of train yourself to always put them in there. It is important to keep that updated so you know what packages are required. Okay, so we can go ahead and add these lines to our description. So I'm going to copy that. Let's go back here and add that. I don't think it matters where you put it, but typically people put it right here. And okay, so let me describe the difference here between depends and imports. When you're beginning, you just stick everything on depends and not worry about it. But there is a difference. So depends on everything on the line on depends is going to be available to the user at the command line. So because I put ggplot2 up here, that user doesn't have to call library ggplot2 to be using ggplot2. If they load my package, they've also got access to everything in ggplot2. Imports are things that my package uses, but are not going to be available to the user. So they do need to have it on their machine, but they're not going to be able to type a function from forecast. So, like auto ARIMA it says it's not found. Auto-remit is the function that is in little forecast. But if I type ggplot, it knows about it. So that's the difference between depends and imports. Like I said in the beginning, when you're first developing packages, I would say don't really worry about it. Stick everything on depends, make it simple. And then once you get comfortable with it, and then you might start thinking about, okay, do I really want, do I really need all of the functions from these packages that I'm using? Do I really need the user to have those available? And you might think, well, that doesn't matter. What does it matter if they're available or not? Well, it can matter because you don't know what other functions that they have defined or whatever packages they have defined and that they're using, and you don't want to create any conflicts. And so typically what people do is they put as few things as they can up here in depends. Just make sure they don't have any conflicts for their users. Okay. Great. Looks like somebody had a problem, and okay, looks like it got solved. Okay, great. Thank you for those helping out there. All right, so let's, okay, so we've added a new function. Next, what we're going to do is we're going to add some data to our package. So let's go back to the base level. So we don't have a folder for data yet, and let's create that. And it must be called data, little data, so D-A-T-A, not capital D. Okay. So now I've got that, and now I'm going to go and I'm going to just make some data here. Make this data set. That's called www2, which is just going to be the square of the www usage data set. And then we're going to save that as a data file in that data folder. And it's important that the ending is capital R, capital D, A-T-A. We'll paste that code in, save it. Now, when we look in data, we have it. Great. All right, so we're going to install and restart again. So just because we put it in there, it's not part of our package yet because we haven't built our package. So we need to rebuild it. Let's go ahead and do that. Okay, so Elizabeth had a question. I'm getting this error when I do install restart error dependency forecast is not available. So you don't have forecast installed. So you need to go to the packages tab in the lower right panel, click install, and then type forecast. Oops, forecast. Go ahead and install that. Sorry, I should have mentioned that. Used a more common package. Okay. Great. Okay, so what did I just do? I created www2 data, put it in my package, and let's look over the dependency because we have a little special line here. It says lazy data equals true. What that means is that all this data here is immediately available to the user. And so that would be the common thing that you would see in a package, but every so often you'll see this as false. And in that case, you're going to have to specify in your namespace that you export data sets to the user. But if you do this line here, it's just going to export everything. So now if I say www2, let's go ahead and remove. Okay, what you're seeing here is that I just remembered that when I created WW2, I put that in my environment and then I saved it. And then, so definitely when I type WW2, it's going to appear because I put it in my local environment, but it's also in the package. So even if it's not in my environment here, I'm going to have access to it. So let's do this. It's not going to remove the data in the package. That's its own separate thing. All it's going to do is remove it from my environment. It's gone there. So it's still there. So what happened? So it wasn't in my environment. So what's going on is it's in the package. It's using the data in the package. It lazy loaded it. Okay, so now what I can do is I can use that. Let's see here. I had a little thing, right? So I can take a little forecast on WW2. So there it goes. So this is the square of that WW usage, and it did a little forecast. It used the default value for the projection, which is 10 years. This is why that looks shorter. Okay. So I think that those are the key things there. The data aspect is really nice. You can always, easily include data for your users, for yourself, and don't have to be like, running code to like recreate that and like reading in the data files and creating that. Is there a way to view the package environment objects? Yes, it is. And I can't think of it right now. There is a command where you can do something like data sets or something, and you can specify what package you're looking in. Okay, let's see. I want to show you one other folder that is handy to know about. So you can create this folder called INST, and that's where you could put things that you don't want to be part of your package. Just like maybe you have the code that was processing your data, and when the user installs the package, you don't want them to have that. So you can put that in inst, and then within inst, it's kind of weird, but you can make a folder called doc, and that will be given to the user when they install the package. And there's probably historical reasons for this. I'm sure there's historical reasons for the structure of the inst and then the doc. But that's it. The doc is good to know about, because if you have like manuals or other documentation that you wanted to give to the user, that's where you put it, in this doc folder. And then I'll try to remember next week to show you there's a command that the user can call to bring up any documentation. Or they would just look in this doc folder. They would see that when they download your package, they would see this, and they can go there. Okay, great. So that is basically it for package structure. I'm now going to move on and talk about how you can share your package. So if there are more questions, I will take those. Just sort of general questions about package structure. What about the man folder? Okay, that's a good question. So the man folder is your documentation. And in the template package that RStudio made for you, they created a man for a manual page for hello. And it's I forget the name of the this code, but it looks like this. And so if I do $hello, that documentation is going to show up over here. So nowadays, people don't write their own RD pages in the man folder. That actually, like the organization for that, it just becomes a nightmare for a big package. What the way that it's done now is something called ROxygen, and it's some commenting that you put actually in your function file at the top of your function, and then you document at the top of your function, and ROxygen is going to make this file for you. So you don't actually touch the man folder anymore. Everyone uses ROxygen. So I'm going to show you how to do that, how to use ROxygen next week. Okay, great. So we're going to move along, and now I'm going to talk about how to get your package up on GitHub. It's going to be similar in GitLab if that's where you're going to be sharing your package. And this way, people can install your package easily. Okay, so I'm going to show you this with GitHub Desktop. And on the web page here, if you scroll down, it's going to show how to do this from RStudio without GitHub Desktop. So if you're not using GitHub Desktop, or if you're using GitLab, you would do something use these RStudio instructions also, because I'm going to show you how to publish with GitHub Desktop, and you can't publish to GitLab with GitHub Desktop. You can push, you can interact with it just fine, but the publishing part doesn't work. So I showed you the instructions for RStudio, but then I noted at the bottom that I don't personally use those instructions. So either I'm going to use this GitHub Desktop method that I'm going to show you now. You're going to see how easy that is and why I use it. And if for some reason I can't do that, instead of using all those steps there, I'm going to just create a new project on GitHub or GitLab, and then I'm going to pull it into RStudio using that new project version control URL. So I'm just going to make a blank one, and then I'm going to copy my files into that new blank repository. I just personally find that way faster, and then I don't have to remember all these instructions. But I wanted to give you the proper way with all the instructions so you know it. Okay, so let's go here to GitHub Desktop. And so I have made a folder, and I checked that little box to make it a Git repository. So I'm going to go down here. So now I'm going to go here, GitHub Desktop, and I'm going to go to File, Add Local Repository. Local repository means it's on my laptop, and it's already been made a repository. Because it's made a repository because I clicked that little button. Let's see, and I'm putting GitHub. Let's see, okay, and I called it My New Package. Select. So now I'm going to add it. Okay. There we go. And, oh, it looks like I haven't committed my changes. So let's go ahead and commit these changes. I'm doing one little commit comment for a whole bunch of changes. I'm doing that for the class just to be fast. If I were doing this for a real project, I would be going through and just selecting the ones that are having to do with sort of common things like, you know, replacing the name of something. I don't want to use one comment for a huge bunch of things, because if I have to go back and find the change or revert the change, get rid of the change, I just makes things harder if I put it all into one comment. Okay. So now I've committed those changes, and now you see in GitHub Desktop, I have this publish thing. Use the name. No, I don't want to keep it private. Add. Publish. Okay, there we go. So now it is up on GitHub. So let's go. Okay, so now we're going to go over to GitHub. All my repositories, and here it is. It's up here now. Great. All right, so what does that do, having that up there? So now, if I want to share this with somebody, I can just tell them the location of that repository. One, they could go there and see it. But more importantly, they can install my package right from GitHub. So this is the instructions. They need to use the package DevTools. So if you don't have that already, you need to install it. And then it's install GitHub, and then it would be EEHolmes, my new package. In GitLab, similar, it's install GitLab new package. If you're using the internal GitLab account, so remember those that server for repositories is only available if you're on the Northwest Fisheries Science Center network. So you would only be able to install packages if you're within that network, if they're on the internal GitLab. If you're on GitHub and it's a public thing, then anyone could install that. So let's see. Some other nice things about having your package up on GitHub or GitLab is you can make releases. So let me show you how that works. One of the things can happen, like if you're making a code set for other people, it's really important that they're using the latest version of it. But like when you're working on something, you have a release and you're like, okay, this is it. This is the version I have now. And then you're going to be doing some more work. So you might be doing work within your repository, but you're not really ready to say, okay, this is a new release and everyone should change to this new one. So what you can do within GitHub and GitLab is you can create a release. So in GitLab, it's called a tag. It functions the same way. Here, I can do release, and I create a release, and I give it a name. Target master, so it's not a branch, it's just the main. There's only one branch, so that doesn't matter. Okay, so this is first release. Hello, and great, and publish it. So now I have a release, and now the nice thing about that is when you give people instructions for downloading, you can, for installing your package, you can put this at $release, and it'll automatically go to the latest release. You can also put the tag name on there, and it could go to any release that you wanted. But typically, you're directing them to whatever the latest one is. So you don't have to keep updating that code when you put new releases. It'll automatically send them to the latest release. Another nice thing is that it's really easy to create a nice little landing page. All that you have to do is create a file called README. So this is my package install. So this would be a typical thing, would be that you tell them how to install your package. And then I save this as readme.md. Okay. Good, I've got that. And now I'm going to go back here. So I've jumped back over to GitHub Desktop. I'm fine with the commit thing here, which says create README. I'm going to commit that. And now I'm going to push it up to GitHub. Now click over to back to GitHub and go here to my new package. And you could just leave it like that. It'll show up at the bottom. For my packages, I'm always going to make a landing page because I don't necessarily want just, regular users, see all this code. I mean, I don't really care if they see it, but that's not what they're coming there for. They're coming there to get the package. So I want to direct them to the key information. And so if you go here, you can make it so that instead of seeing that README at the bottom, you can create a little bit nicer landing page. You have to go into settings. All this is on the web page, so you don't worry if you don't remember this. And you scroll down to GitHub Pages. You say Master. Choose a theme. Choose Slate. Select theme. And that's it. And now what it does is it created a little landing page. Let's see if it's up. It usually takes a few minutes. So I'm not pausing it. Looking up. Oh, there it is. Yeah. Okay. It hasn't put the theme on yet. That'll take a few minutes, but you can see that it's created this little landing page. So like I said, I usually do this for my big public projects. And that way I just share this little landing page with them and they go right to here. Once the theme is up, let's see if it's up yet, not yet. Once the theme is up, there's also going to be a link to take them right to the repository and they can see all the code. If you go to onto my repository and you go to my organizations. So organizations is going to be all the public products that I'm creating for NOAA fisheries. The one under EEHolmes is just, like this little test package or something. It's not actually a public product yet. But if you go here, you're going to see a lot of examples of different kind of readmes and how you can create that. I personally now use package down for my packages. I'm going to show you that next week when we talk about documentation, because it's really easy to make a nice online navigation tool for all your documentation. Okay, so that's it. That's how easy it is to make a package and create something that's easy for other people to install. I'm going to stop there. Let's see if there are any questions. If there's not, I'll talk with you a little bit about debugging tools. If you, when you try this out, if you run into trouble, just ping me on email and I'll walk you through it. Like I said, but though usually it works pretty well in our studio, it's just that our coolest thing can be a hang up sometimes for Windows users. All right, let's talk a little bit about debugging and some of the tools I use. So a caveat here, like I'm not a master debugger, and there are debugging tools in our studio. I don't use them that much myself. I do use the package checking feature, and I'm not going to show you that today because we're going to talk about that next week. That's actually a really great part of the documentation. It's this kind of integrated like testing system for your packages, because what you're going to learn next week is how you put this these comments at the top of your code. It's going to tell about what that function does, but you're also going to be able to put an example in there, example of using the function. And when you do check package, it's going to run that example and it's going to make sure your function still works. So that's a really key part of the workflow to make sure that everything is functioning properly. What I'm going to talk about right now are just some really simple debugging tools that I use a lot. So first one is the debug and undebug. So debug function, you can use that for any function in R. I will, if you do debug plot, say, and then you do plot, it's not going to immediately plot. It's going to take you into the function, and then you can step line by line through. And then when you're done debugging, you do undebug. And when you are in debug, you're going to be on the browser, and you can kind of interact, and you can see what values are within the function. So I use that all the time. But sometimes I want to go to a specific place that I know is causing problems. And in that case, I would use a browser. And let me show you quickly how that works here. So going here to the file here, little function. So I could do a browser here. Because this is a package, I'm going to have to rebuild it to get this change in effect. If this were a script, I could just source it. So if I were actually debugging this, I would probably just source it. Anyhow, so now if I do little forecast WW2, you see I've jumped in here and I've stopped right here. And then I have to do capital Q to get out. You can do that in any of your functions to dive into them. Get rid of that. Okay, so let's go back here. Sometimes you don't know where you want to stop. So if you use this code at the command line, options error equals recover, what's going to happen is when you have an error, you jump into that browser, and that can allow you to figure out what's going on with what variable is causing the problem. Another thing to know about is the traceback. So if you run into an error, you don't know where it is. You know, a lot of times in R, you get these errors, and they're pretty cryptic. So if you run traceback, it'll tell you exactly where it ran into trouble. In RStudio, there's a setting where it'll automatically show you the traceback. I don't know if that comes on by default. If not, you go into project settings. Some other ones to know about is like figuring out why your code is running so long. So system time just tells you how long it runs, but that's not so helpful. I mean, it can be helpful. But really good ones are to know how to do profiling. So, so here's an example of profiling. So let's say you have this line of code, which is a matrix, and you're going to take the transpose of that matrix and then multiply itself. So this is called a cross product. And you weren't sure which of these parts of this were really slow. Is it the transpose that's slow, or is it the multiplication that's slow? So if you ran this code here, what you would see is this output, and it shows you that this part of it is the part that's super slow. So that's what's taking a long time, is that multiplication. And so then you might come up with different ways that you can do that multiplication to maybe speed things up a bit. And a thing that is nice for comparing different functions, different approaches for doing things, is this package called MicroBenchmark. And with that, what you can do is you have MicroBenchmark, and then you have these different things that you want to compare. So in this case, they're doing these really simple things, but this could be like two different functions that you're comparing. And then you can plot out the time that things take. So that is really helpful for figuring out what is slowing down your code. If you use debug or browser, will local scope variables show up in the environment window? No, they won't. That would just be your global environment. But you will have access to the function environment. So anything that's being defined within the function, you'll have access to that, and you can look at it, change it, do whatever you want to it. Okay. So I think I will stop there because it's 11, and I'll stay on and answer any questions that you have, or feel free to ping me afterwards and ask your questions. And next week, we're going to talk about documentation. I know that sounds like, oh my God, Eli, that is such a snoozer. I don't care about that. But I will say that, it has really changed my workflow a lot, really improved my code to learn our Oxygen. It's not very hard. It's really not hard. So I really encourage you, even though it sounds, documentation sounds like a snoozer, to check in on that. I'll show you some really exciting things that you can do to make your documentation so much better and really so much easier. Yes, it is O2, or oxygen. Oh, and R Markdown. I added a whole bunch of great things to the R Markdown. I put them in the email. I gave you some more realistic examples of how to make lots of functions in R Markdown. Sorry, not functions, tables. How to do tables in R Markdown using functions. So like if you need to make the same table for 90 different populations, how to write a function for that and just pass the population name and the data set to that function. It's not intuitive. So look at report tables, or just look at the tab here, and more R&D uses. You see that down here. This, and I also put this journal article, which is absolutely realistic journal article. It's the latest article I wrote. It has all the pieces. I kind of cut the article a lot to make it shorter, but it has all the nitty-gritty pieces to it. All right, so I'll see you next week. I'll stay on a few more minutes just to see if there are questions, but otherwise, I'll see you next Friday. Have a great weekend.
Hey, Stuart, can you let me know when to stop the recording and end the meeting?
Yeah, looks like
whatever works for you. I'm not in a hurry to stop it.
no, it's not sharing. It's not sharing. Okay.
Okay.
Looks like we're good. You can stop it.